All right, let's dive in. I think we're definitely past the point where we just high-five an AI for getting one
Oh,
answer right.
oh, absolutely. It's so much more complex now.
We're dealing with these multidimensional goals. We need the model to be accurate, but also, you know, concise.
And maybe output a specific JSON format all at the same time.
Exactly. It's a huge balancing act. And that brings us to this new paper from NVIDIA and some others, GDPO.
Right. Group reward decoupled normalization policy optimization.
It's a mouthful, but the mission here is pretty critical. They're basically saying the industry standard method, GRPO, is, well, it's breaking the training signal.
Breaking is a good word for it. The paper really focuses on this one specific problem they call reward collapse.
Okay, reward collapse. What does that actually mean?
It all comes down to how we add up the scores. In the standard approach, GRPO, you take your different rewards, say one for accuracy, one for being brief.
And you just sum them up.
You just add them into one big number. And that's the trap. Because you're ignoring scale variance.
It's covariant.
Yeah, imagine your accuracy score is just a 0 or a 1, correct or incorrect. But your brevity score might be on a scale from 0 to 100.
Ah, so the brevity score just completely drowns out the accuracy score.
Exactly. The model learns really fast that the easiest way to get a high reward is just to focus on that big number and pretty much ignore the small one.
So it flattens the signal. It's like you
Yeah.
lose the resolution on what actually matters.
You do. You lose it. The paper calls it a low-resolution training signal. And once you've mixed it all into a smoothie, you can't taste the individual ingredients anymore.
So how does this new approach, GDPO, fix that?
Well, the key is right in the name. The D is for decoupled.
Decouple.
Yeah, so instead of summing everything first, it decouples the rewards and normalizes each one independently, based on its own little distribution.
Okay, so you're putting them on a level playing field before you combine them.
Precisely. The reward for accuracy is judged against other accuracy scores. The reward for brevity is judged against other brevity scores. Nothing gets drowned out.
And the results they show in the paper are, well, pretty stark, especially for tool calling.
Oh, absolutely brutal for the baseline model. They tested this on Quinn 2.5, asking it for these really rigid formats.
And in tool calling, if you miss one bracket or one comma in the JSON, the whole thing just breaks.
It's not just bad style, it's a runtime error. And the paper mentioned that the standard model sometimes hit, what was it, 0% compliance?
Zero. It literally couldn't learn the constraints because the signal was just too noisy. But GDPO consistently nailed the syntax.
Right, it turns a potential crash into valid code.
They also ran this on the AA math benchmark with DeepSeek R1. This is the one that really caught my eye because they were testing accuracy and conciseness.
And this is where models love to find cheat codes.
You mean it just optimizes for the short reward and tanks the correct reward?
Often, yeah. The easiest way to be short is to output nothing, or just some nonsense. It games the metric.
The GDPO stopped that.
It did. It improved accuracy by up to 6.3% while keeping the answers concise.
And a 6.3% jump on a math benchmark is not a rounding error. That's a huge leap.
It is. It shows the model isn't just compromising, it's actually getting smarter at balancing those trade-offs.
So what's the big takeaway here? It feels
Yeah.
like we're realizing simple arithmetic just isn't enough for complex alignment.
I think it proves that you can't just average out your problems. If you want a model to be multifaceted, you have to preserve the distinctness of each goal during training.
Which, leaves us with a pretty heavy question to wrap up on.
Hmm.
If the math is this tricky just to get an AI to balance being right versus being short,
Yeah.
what happens when we try to align these things on dozens of really complex, really messy human values all at once?
Mm.
Like safety versus censorship or helpfulness versus harm.
Does the math even hold up then? Or do we need an entirely new paradigm?
It's something to calculate on your own time. Thanks for diving in with us.